bench this time, I have an EMS VCS3, also known as the Putney. And instead of going on about all the famous artists who use this or talking about the On the Run sequence, I'm just going to focus on the repairs because that's what you're here for, and you can look all that other stuff up on the internet. But there's one notable thing about this particular VCS3. It comes with the DK-1 velocity sensitive keyboard. And this particular keyboard, if you can see there on the top, has been signed by Alex Lifeson of Rush. So supposedly he signed this during a high school reunion. And there's some other writing on the inside, and there's a decal on the side of the synth here that also supports that fact. But the keyboard is completely dead. It does not work at all, so we'll just put it aside for a moment. The VCS3 is almost dead as well. I will dare to turn it on even though I'm expecting the power supply to fail at any moment. I've been through all the sections of the synth and everything is extremely flaky or doesn't work at all, but I can make some noise happen. The vernier controls on the oscillators, the control for oscillators 2 and 3 don't even turn anymore, and the one for oscillator 1 is on the verge of collapsing. It's kind of coming apart as I turn it. So as you probably know, the patching between the various components on an EMS synth is done through the patch matrix. So the sources come in on the rows here on the left, and the destinations go out the columns off the top. And from previously playing around with this synth, I know a few things work. Oscillator 1, the filter, and the reverb kind of work. So we'll play around with those. So I can take the source of oscillator 1, which happens to be row 2, and I can put that out through the main output channel number 1, which happens to be column B. So I put a pin in, and there you can hear the sound, and I can change the frequency with the vernier knob here on the top. And oscillators too, and I'll just patch them in like they're basically dead. There's nothing coming out of them, and the noise is also dead. That's the noise source. I'll just play around with what works right now. So there's oscillator 1. I can also take the source of oscillator 1, and rather than going directly to the output, I can put it through the filter. So I'll take oscillator 1 source and put it through the filter input, which is this column here. Now you don't hear anything. You can think of the signals as coming around the patch matrix in like off the top and in through the side. So the filter then becomes a source, and then I take the filter source and I put it through output channel 1. And now I can play around with the filter cutoff here, which sounds very EMS-like. Let's use a joystick. I can use the left-right movement of the joystick, which is a source coming in on a row, and I'll use that to control the frequency cutoff of the filter. So I take the source for the left-right motion of the joystick, and the filter frequency cutoff is this column. Now I can use the joystick to do that. Sounds kind of cool. It's kind of fun. Okay, let's get a little dangerous. So I'll take the filter output that used to go right to the main output of the synth, and I'll put that through the reverb. So I'll take the filter source here in the row, and I'll make it go out the signal input column for the reverb, which is this pin. Again, you may be able to hear that through my microphone because I can hear the spring reverb making sound. Anyway, but you can't really hear it on the line out, so I'll take the reverb source and I'll put it out through output channel 1. It's a bit of a distorted mess. You can hear that spring reverb. Oh, let's do something else. Let's take, whoa, oh my gosh. let's take, let's use the vertical movement, the up-down movement of the joystick to control the frequency of oscillator 1. So again, the up-down, the vertical movement of the joystick is a source on a row, and I'll make it go to the destination of the oscillator 1 frequency control. That's pretty cool. We're making noise. Ooh. It's very, very EMS-y. Okay, woo, that's enough. Wow. Okay. Well, let me turn this off. I'm also getting a little paranoid about the power supply. So some things work and you can make noise, but basically there's a lot of flaky stuff in this synth. As I said, 2 of the oscillators don't work. The noise generator doesn't work. The ring modulator does something, but it's not what it's supposed to do. The envelope generator kind of works, but usually when you hit the attack button, which triggers the envelope, it just pulls a whole bunch of current from the power supply and everything shuts down for a second. So this is going to end up being more of a restoration than just a repair. So let me just open it up and get to it. I'll be narrating here in the background while you watch me work. Once the back's been removed, it exposes the 3 main circuit boards, and in the schematics, they're labeled boards 1, 2, and 3 from left to right, or alternately boards A, B, and C. First, I'm removing board C, which contains the 3 VCOs, the noise source, and the meter circuit. Next is board B, which contains the envelope generator, the diode ladder filter, and the ring mod circuit. And the input channel amps are also on board B. And finally, board A, which contains the main power supply, the audio amp circuits, and the spring reverb amp. Here, I'm taking detailed photos of both sides of all 3 boards, and this will help me later on if I have questions about component placement or polarity. And it also helps me identify component failures like these burnt out resistors. The first thing to repair is the power supply circuit. The power resistors in the original circuit were quite under spec, and that caused overheating issues, which then caused other component failures. So here I'm replacing those resistors with higher rated ceramic resistors. I'm forming the legs of the new resistors to allow them to stand off from the PCB and dissipate heat better. I also found that 2 of the 3 power transistors had failed. Those are the ones with the big heat sinks, so I replaced those as well. Here I'm mixing and matching parts from the original vernier controls with some modern replacements, and I'm trying to keep the old dial faceplates and knobs so that the synth doesn't lose its vintage look. So I'm about halfway through recapping the circuit boards and replacing the corroded trim pots with new ones, and various parts of the synth are coming back to life. However, when I got to the meter, it didn't come back to life. I think the meter is really underrated on the VCS3. It's really useful for visualizing control voltages and also rudimentary setting of the different audio signal levels. So let me show you what I would expect to happen with the meter. So when I turn the machine on and change the meter control to control voltages, and then patch something in, like say the joystick, I'll do that right here. As I move the joystick left and right, I'm expecting the meter to move left and right with the joystick. However, it just stays pegged to the left. Similarly, if I put the meter control to signal levels and then patch in a signal like say oscillator 1 and then say crank the level here of oscillator 1, I'm expecting the meter to rise and show the level of the audio signal of oscillator 1, but it doesn't. It just stays on 0. So obviously there's something wrong with the meter circuit, and the first thing I do in this situation is look at the schematic. So let's go do that. Here's an excerpt of the board C schematic showing the meter circuit. The meter is in the lower right here with a switch to choose between an audio signal source or a control voltage source. The input to the meter is on the lower left, and the terminal labeled J9 corresponds to the meter column on the pin matrix on the actual synth. The voltage from this terminal is fed to the base of an NPN transistor, effectively turning it on, and the current flowing through the NPN transistor develops a voltage on the base of a PNP transistor, causing current to flow through it. Now, the current flowing through the PNP transistor can take two paths down to the meter. The first path is for audio signals, which are AC, so they go through a coupling capacitor. The second path is for control voltages, which are DC, and they go directly through a current limiting resistor. So after looking at the schematic for the meter circuit, and with a little bit of experience and kind of a hunch, I think it's the PNP transistor that's in that circuit. And it's located down here on board C. And I have my voltmeter bridged across the base and the emitter on that transistor. And because it's a PNP transistor, I'm expecting a voltage of about, I don't know, maybe -5 to about -7 volts while I, feed something into the circuit. So let me turn the synth on and we'll see what the voltmeter shows. It's showing about -1.7 millivolts, so that's much lower than I would expect. But let me play around with the signal going into the circuit. So I have the joystick mapped into the meter, and I'll move the joystick all the way to the right, and the voltage does go up. It goes on the base of that transistor. It goes up to about 1.9 millivolts, minus 1.9 millivolts, and if I go all the way to the left, it goes down to about minus 1.5 or 1.6 millivolts. So that's not what I would expect. As I said, I was expecting minus 0.5 to minus 0.7 millivolts. So I suspect there's something wrong with that transistor. Let me pull it out of the board and we'll test it. Here I'm desoldering that suspect PNP transistor, and it turns out that the negative power supply rail was basically unregulated because of a failure in the power supply circuit, so almost every PNP transistor in the synth was blown. I'm going to test this PNP transistor with one of my favorite pieces of old gear, which is this 1990s Radio Shack digital voltmeter, and it has a transistor checker built into it. So let me connect the leads. I made a little jumper cable with some of these clip leads, just makes it easier to connect. Now what I'm expecting is that it will show that it is a PNP transistor, and it should be emitter collector base as the leads, and the gain should be somewhere around 200 or 300, should be a few hundred. So let me turn it on, and then I'll hit the transistor check button. And it thinks it's an NPN, which is wrong. It thinks it's collector base emitter, which is wrong. And now it's trying to show the gain or the beta for the transistor, and it just sits there. It can't actually calculate it. So that pretty much tells me that there's something seriously wrong with this transistor. Now, this is just a standard PNP low signal transistor. There's nothing special about it. So I'm going to replace it with a common 2N3906. It's probably the most common Jelly Bean PNP transistor there is. And this isn't the first one I've replaced on these boards. As I've been going through, I've found quite a number of blown PNP transistors, probably due to power supply issues from the history of this machine. The only thing that's a bit weird is that the pins on the 2N3906 aren't in the same order, but I just swapped two of the pins. So let me take this transistor, solder it into the board, and then we'll check the meter again. Okay, I've installed board C back into the synth with the replaced PNP transistor, and I'll turn everything on, and let me patch the joystick into the meter. Aha! Success! As I move the meter or the joystick back and forth, it changes the control voltage, which is reflected in the meter. Let me try the vertical motion of the joystick. Yeah, that works too. Oh, and the last thing is, let me switch it to signal levels, and then I'll patch in the ramp wave from oscillator 1, and I'll slowly turn that up. And as I turn up the oscillator, you can see the meter changes with the audio level change. Let me put it back to the joystick because that's just so cool. Okay, excellent. One more thing working. At this point, I've completed the repairs on all of the circuit boards, and I have all the functionality on the VCS3 working again. Mostly, I replaced all the electrolytic capacitors, replaced all the trim pots, and then there were various, blown transistors and things like that. The meter circuit wasn't working. That was a transistor issue. The envelope shaper wasn't working, and again, I just replaced the blown transistors. There were some mechanical issues with the 3 oscillators with the vernier dials, but that's been resolved. There were some other various issues, a bad solder joint, some blown resistors, some burnt out resistors from when the power supply wasn't working, which is what I want to talk about right now, the power supply. So this is card number 1 in the VCS3, and it has the power supply regulator circuit and also the circuits for the 3 audio amplifiers. So there's an audio amplifier for each of the outputs, channel 1 and channel 2, and there's also a separate audio amplifier for the spring reverb circuit. First, the power supply. There are 3 main voltage rails inside the VCS3. There's a positive 12 volt rail, negative 9 volt rail, and there's also a positive 11 volt rail that's used as an auxiliary voltage for the audio amplifier chips. And the main current for each of those 3 voltage rails goes through these 3 power transistors, the ones with the heat sinks here that I'm pointing to. And 2 out of 3 of these were blown, which was causing the negative 9 volt rail to be completely unregulated, and it was like minus 20 volts or something. And also the 11 volt rail, which isn't really regulated, but it was also blown, so it was floating higher than it should have. And what that did was that caused a cascade of failures. One of the audio amplifier chips blew, and there were a lot of PNP transistors that were dead. I started just replacing all the PNP transistors as my first diagnostics for things that weren't working, because they were just blowing all over the place. And the eagle-eyed among you will have noticed something very interesting. These are the two amplifier chips for channels 1 and 2, and this is where there should be an identical chip for the reverb circuit. So what the hell is this? Well, the audio amplifier channel that died was actually channel 2. Now these audio chips, the PA234s, they are basically unobtainium. You cannot get them anymore. Obviously, they haven't been manufactured for decades. Basically, the only place to get them is another broken VCS3 or a Synthy, or maybe some obscure audio equipment from the early 70s. So I took the two remaining working chips and I put them on channels 1 and 2. Really, I just moved the reverb chip that was still working over to the blown channel 2 position. So what was I going to do for the final reverb channel? Well, what I did was I designed and built a little daughter board, and I used a TL071 op amp to basically simulate the audio chip functionality. It's a little cleaner than the original chip, but it restores the functionality of the synth. And sometimes when you're restoring these old guys, you just got to do what you got to do. So I got the reverb working again. It sounds a little cleaner than it used to originally, but at least it's working. So now that I have a working VCS3, I can start working on the keyboard. I have the keyboard partially disassembled, and it doesn't look too bad on the inside. I'm not 100% sure why it was completely dead when I tried it the first time. However, there are some clues. If I flip the main circuit board over, you'll see there's a film capacitor and it's just dangling on one leg. It's not connected to anything. So I have to figure out where that's supposed to go. Also, I can see that there's some components just missing from the circuit board. I can see the flux residue on the back side, but the components are just missing on the front. Luckily, I have the schematics to the DK-1, so I can figure out what those missing components are. Another thing to consider is that the main unit, the VCS3, its negative 9-volt rail was completely unregulated, and at some point I'm assuming that the keyboard was plugged into the VCS3 when that was the case, so there could be all sorts of other blown components here. There's some transistor array chips, there's some discrete transistors. I can see some of these trim pots are all corroded. So what my plan is to just repair the obvious stuff, plug it in, and then start going through some diagnostics. I did the minimum amount of repairs on the keyboard to dare plug it back in, and I am getting sound, but the tuning is way off. It's not performing how it's supposed to. Before I get into the details, I wanted to mention that the DK-1 and DK-2 keyboard controllers also have a built-in oscillator. So in addition to the keyboard CVs, there's a built-in oscillator that also tracks what you play on the keyboard, and that's what we're listening to right now. So it's not the oscillator that's in the VCS3, it's the one built into the keyboard. Now there's a few things I noticed right away. The first thing is when I press a key, I should see the envelope generator get triggered, and that's not happening, so I have to figure that out. The other thing is the tuning is way off. If I play the extreme notes on the keyboard, it doesn't even play an octave. So the scaling is way off. And if I turn the tuning spread knob on the controller here to change the length of the octave, this is what happens. So that's pretty disastrous. I'll have to figure that out. The other thing is there's also a frequency knob that changes the bass frequency of the built-in oscillator so that you could tune it with the oscillators on the VCS3. And if I play with that, this happens. It kind of cuts out at the top. It just suddenly stops, and at the bottom, we get this. Whoa, what a mess. So I'm probably going to do some quick cleaning on those pots just to stabilize things a bit. Another thing I can do is, rather than listen to the internal oscillator, I can change output of channel 1 from the signal, the oscillator in the keyboard, to just the keyboard CV, and then I will patch that into the frequency mod of oscillator 1, and then I'll just put oscillator 1 on the VCS3 right out to the speaker. There we go. So now we're listening. Whew, that's a bit loud. So now we're listening to the oscillator in the VCS3. Again, the tuning is way off. So there's obviously something wrong with the scaling. Okay, so at this point, I'm going to go back to the circuit board and I'm going to trace out the CV scaling circuit and also figure out why the trigger signal isn't actually causing the envelope to go off. I should explain how the signals from the keyboard get patched back into the synth. So there's a cable that connects the keyboard and the synth, and the VCS3 supplies the power to the keyboard, and then there's some other lines that go in the other direction for the signals from the keyboard to go back to the synth. Now the gate signal is fixed. It's permanently patched into the trigger for the envelope, so you can't patch or change that at all. And there are 2 additional lines for the remaining 3 signals, and they come in on input channel 1 and 2 on the synth, and you can patch them wherever you want, and they come in here through the patch bay. On the DK-1, there are 2 toggle switches, and you can choose 2 of those remaining 3 signals to go back to the synth. So for input channel 1 on the VCS3, you can choose either signal, which is the sawtooth VCO that's built into the keyboard. So that's an audio signal to go to input channel 1, or you can choose the keyboard voltage, which is the pitch CV, to go into input channel 1. This other switch is for input channel 2, and you can choose the dynamic voltage, which is the velocity CV of whatever key you're pressing, to go to input channel 2, or you can also pick the pitch CV, the pitch of whatever key you're playing. So out of the 3 remaining signals, you can choose 2 of them that go into input channels 1 and 2, and then you can patch them in through the patch bay. So, you know the problem I was having when I had the keyboard connected, where the envelope generator was just on all the time, and I thought it was an issue with the keyboard? Well, it doesn't have anything to do with the keyboard, because when I disconnected it, the problem remains on the main unit. So the envelope generator is on all the time. Here I've got oscillator 1 connected through the envelope in the VCA. And I have all the controls on the minimum values, and push the attack button. It's just on all the time, and you can see the light remains lit. Here, let me turn this down. So it was intermittent before, like it kind of did this a little bit while I was doing the previous repairs, but I thought it was a failing transistor, or maybe a capacitor problem, or even there's some steering diodes in the envelope generator circuit, and I thought maybe it was that. It had nothing to do with all that. I've spent a lot of time tracing it down. It ends up that the problem is in the wiring harness. So let me turn this off and put the synth on its side, and I'll show you what I found. I have my multimeter in continuity mode, And one of the probes is connected to the off potentiometer in the envelope generator. And the wire from that lug on the potentiometer is supposed to come down and go to pin 29 on the edge connector for the B circuit board, so B29. So let me come around. It's a little fiddly. I hope you can see this. So that's this connector here, and I'm going to count backwards. So that's 32, 31, 30, 29. So it's this lug here that I'm touching, but you can't hear the meter beeping. But watch what happens when I pull on the lead a little bit. I'll just pull on the wire. Can you see that? When I pull on it, you get the continuity beep. So what this means is that particular wire has a cold solder joint. So I'm actually going to check all of the wires on this edge connector because that's probably not the only one that's faulty. Now that the problems with the wiring harness have been worked out and I have everything connected together, you'll notice that, yes, the envelope shaper, the envelope generator now works. So it triggers on and off with the keyboard or with the attack button on the VCS3 itself. Now, there's still a bit of an issue, as you can hear. The pitch is basically tracking across the keyboard, but there's a little whip at the beginning of each note. And on key up, the CV goes way off the scale and the VCO just goes into some weird high pitch. Now, from experience, I'm pretty sure I know what this is. It's related to the sample and hold circuit that's in the CV circuit. So what's supposed to happen is when you push a key down, it's supposed to sample the voltage representing the pitch of the key you're holding down, and it's supposed to hold it even after you lift the key up. It's not supposed to suddenly go off into some other pitch, or I think what's happening here is it's going to the positive rail because it's going way off the top of the scale. So just to explain in a little more detail what I'm talking about, let's look at this schematic. So each of the keys is represented down here at the bottom by these two rows of switches. So when you push a key, it's actually closing two sets of switches. The first set of switches here is just from a resistor ladder, and that's the actual pitch CV. Then just after that switch is closed, like a few milliseconds after that, it closes the second set of keys, which is a gate signal. So let's see where these voltages go. So the CV signal goes up and into this JFET, and this JFET is configured as a switch. So the pitch CV goes up to the drain of this JFET. Now if the JFET is on, it's acting like a switch. This voltage will go right through the JFET to the source, and the thing that turns it on or off is the voltage applied to the gate of the JFET. And you'll notice that's actually connected to the gate signal. So when you push a key down, this JFET will turn on, and the voltage from the CV pitch voltage will go right through the JFET switch and charge this capacitor. Aha! That is the hold part, so it's sample and hold. So this capacitor will get charged to a voltage related to whatever key you're pressing down. Now, that voltage also goes through another JFET, but this one is set up as a variable resistor or a voltage-controlled resistor. And that JFET is part of a voltage divider with some other resistors, and that's actually the CV that then gets sent out through the cable and to the VCS3. Now, obviously, there's something weird happening in the interaction between these two JFETs, because when you lift up the key, obviously, this capacitor is draining immediately. So it's either there's something bad with the second JFET and the gate's not a low impedance input gate, or the first JFET isn't getting turned off and the capacitor is just draining backwards through the JFET. So to cut to the chase, I'm going to just swap out both of those JFETs with new ones. So I've replaced the two JFETs and the keyboard pitch CV sample and hold circuit, and the pitch and stability went away. Let me give you a quick demo of that. So how I have things set up, I'm using the VCO built into the keyboard, and it's going through channel 1 and through the envelope generator of the VCS3. So I'm not using any of the oscillators on the VCS3, I'm using the built-in one. And also I have the decay set quite long, actually, on maximum, so you can hear any drift in the pitch. And here we go. You can hear it's, even when I lift up on the key, the pitch stays stable, how you would expect. Also, the DK-1 keyboard is velocity sensitive. So now that the pitch is stable, let me give a demo of that. So finally, the keyboard is working again. I also have it set up so that the pitch CV from the keyboard is controlling VCO1. So let me turn down the keyboard VCO, and I'll turn up the oscillator on the VCS3. And you can see, oh, here, let me turn up the decay again. So it's also controlling the VCO on the VCS3 without any pitch instabilities. So let me try to do something a little daring to see if I can get the VCO in the keyboard and the VCO on the synth to track. So I just turned up the keyboard level. Whoa, okay, let me tune that. Okay, so they're good on middle C. Let's try over the keyboard. So this is both VCOs at the same time. A little bit of pitch beating up at the top end, but not bad. Another thing I can show you is my graveyard of parts. So in this tray, all the parts that I replaced. So there's some power capacitors, that PA234 amp chip, lots of corroded trim pots, tons of these blue electrolytic capacitors, burnt out power resistors, from the power supply, so many PNP transistors, lots of replacement parts. Oh, and an entire bag of potentiometers that are replaced, both from the main VCS3 and also from the keyboard. So now is a good time to talk about the signature and other markings on the VCS3 and DK-1. So the most obvious thing is Alex Lifeson's signature on the front of the keyboard. Alex Lifeson is a guitarist for the band Rush, and his signature is in this metallic Sharpie, and on the inside, also written with a similar pen, it says A.Y. Jackson Music Department 50th Anniversary. Now, A.Y. Jackson is a famous Canadian artist, and Alex Lifeson went to a high school that's named after A.Y. Jackson, and that is where the keyboard and the VCS3 came from. Also on the inside of the DK-1, there's some initials that says D, and on the bottom of the DK-1, there's another set of initials that say JDM. Now, I have no idea who those two people are. Perhaps they worked in the music department, or maybe they maintained or managed this particular synthesizer. Also, on the side of the VCS3 and on the side of the DK-1, there's a North York Board of Education decal, or decal if you prefer. And finally, on the back of the VCS3, kind of scratched in rather roughly at a weird angle, it says 12IX72OK. So I'm assuming that means the 12th of September, 1972. And I don't know if the OK means that's the time, or that's the date that this particular machine came from the EMS factory, or if in 12th of September 1972 somebody did a tune-up and they were just scratching in that on that date everything was calibrated and tuned. We may never know. But we know that this synthesizer is at least as old as the 12th of September 1972, and that kind of makes sense because this is definitely an early model of the VCS3. Basically, it's a Mark I. So at this point, I'll conclude by playing out the video with a track I recorded to exercise all of the functionality of the VCS3 with the DK-1 keyboard. Thanks for watching.